And then, yeah. Okay. So today we're presenting our analysis of the 2024 NBA Finals with a focus on predicting games uh, win probability. This project is framed around a real-world application, with being how a sports betting service in Oxford can use data to set better odds and make more accurate predictions for high-profile games. Our goal is to explain not only what we found, but why it matters for decision-making in sports betting.
Okay. Our client is a sports betting service that wants to know which single game statistics best predict who will win an NBA Finals game. In betting, small errors can mean large financial losses. If odds are set incorrectly, the company becomes overexposed, especially during high volume events like the finals. With only 5 games in the series, the company needs to understand which statistics are consistent and reliable and which ones vary so much that they should not heavily influence betting predictions.
So, why the problem matters. This problem matters because inaccurate odds create financial risk for betting companies and loss of trust for companies. Bettors expect predictions to be based on data, not opinions. And also, finals games involve small sample sizes, so identifying which statistics remain stable from game to game is essential. Our data shows that points scored are fairly consistent and useful for prediction, but turnovers are much more volatile, which makes them harder to rely on.
Our research questions is we focused on 2 main research questions. The first, did the Celtics score more points and commit fewer turnovers than the Mavericks did during the finals? And second, how strongly do points and turnovers predict the probability of winning a finals game? These 2 questions help us understand both comparison and prediction, who performed better and what actually drives victory.
So, for our hypothesis, the for the test, we're comparing the average performance of the Celtics and the Mavericks. Our null hypothesis says the two teams performed about the same, and our alternate hypothesis suggests that the Celtics outperformed the Mavericks. For the regression, win probability is the outcome we're trying to predict. Points and turnovers are the inputs we use to make for those predictions, and in simple terms, we are testing if scoring or mistakes on the court explain who wins.
Dataset overview. Our dataset includes 10 observations. Each observation represents one team in one game, which gives us 2 observations per game across 5 games. The data came from official NBA box scores through NBA.com and Basketball Reference. We collected points, turnovers, rebounds, assists, shooting percentages, and win or loss status. Every data point was checked and no values were missing.
For our summary statistics, on average, the Celtics scored about 101 points per game, while the Mavericks scored just under 100. Turnovers were similar between both teams, averaging roughly 10 per game, and rebounding numbers were also comparable. There were no outliers and no missing values, which means the quality of the data is high. This tells us that even though Boston won the series, their overall performance in points and turnovers was not dramatically different from Dallas.
Hypothesis test results. We used a Welch two-sample t-test to compare average scoring. This type of test is appropriate when sample sizes are small and variances may not be equal. Our test statistic was about 0.3 and the probability value was about 0.38. The results tell us that the scoring difference between the 2 teams is not statistically meaningful.
For interpretation, because the probability value is much larger than 5%, we fail to reject the null hypothesis. That means there is no evidence that the Celtics consistently outscored the Mavericks, and for betting companies, this is important. They should not assume Boston had a built in scoring advantage, and they should avoid pricing bets based on team reputation alone. Game outcomes in this series were driven by game to game performance, not consistent dominance by one side.
Regression model. Our regression model estimates win probability using points and turnovers. The equation shows that as points increase, win probability also increases. Each additional point scored raises win probability by roughly 4 percentage points. Turnovers reduce win probability, but not in a consistent or statistically meaningful way here. This tells us one thing clearly: scoring matters more than mistakes in this particular series.
So the model explains around 68% of the variation in win probability. This is a strong result given that the dataset only includes 10 observations. Points are just statistically significant, meaning they reliably predict winning, and turnovers are not statistically significant, meaning they do not consistently explain outcomes. The overall model also passes the significance test, which indicates the model actually holds predictive value.
Residual analysis. We checked our residuals to make sure the model behaves properly. The residual scatter plot shows points fairly evenly spread above the below zero, which means no clear pattern was missed. The normal probability plot shows that the errors mostly follow a straight line. With only 10 observations, we expect some noise, but overall diagnostics look reasonable.
And recommendations. For a betting company, our advice is clear. First, weight points scored more heavily when setting odds. And second, do not overvalue turnovers in this matchup. Third, avoid reacting to one single game too strongly. Scoring is more reliable across games than turnovers. And in the future, betting models should include full season data instead of just playoff season results.
To summarize, we found no statistical evidence that the Celtics outscored the Mavericks or took better care of the ball. Points scored were the only reliable predictor of winning. Turnovers were inconsistent and not statistically meaningful. The regression model explained a large portion of outcomes despite having only 10 observations. Overall, scoring efficiency mattered much more than mistakes in this final series.